Okay, and we're live. Hi, everyone. Welcome to the book reading club session. This time with Sam and his book, Building Microservices. Thank you so much for joining us, and we're happy to return with the book reading club after a few months without any session. So we're very happy to have Sam with us with his hot topic, microservices, that's been dominating the tech world for the last 3-4 years. Sam, can you please introduce yourself to our audience?
Yeah, so my name's Sam Newman. I'm a developer / ops person. I think some developers think I'm an ops person and ops people think I'm a developer. So that's kind of where I'm happiest, in the middle. I've been working in build automation, infrastructure automation, and sort of architecture in that space the last 10, 15 years, lots of cloud stuff. And so, yeah, most recently I wrote, I think at the end of 2014, I finished my book, and it's been really popular since. And I've been it's been great to see the response it's had. But it's a very broad topic, purposely, that covers pretty much most aspects of software architecture. And so I'm kind of very happy to get into detail on questions on this session today. I think it's the first of 3 sessions we've got.
Yeah, and we're also very happy to have you here with us. So thank you so much for accepting our invitation. And also with us, we have Ivan, my colleague from the Book Reading Club.
Hi, everybody. Good to see you again after so many months, and good to be reading a very interesting book again.
Yeah, and myself, I'm Roberto. So no point in talking so much about me. So let's go straight to the book. Let me open up with one question to Sam, of course, is what drive the motivation for you to write this book? How do you thought about writing the book, and why did you wrote it?
I think there's almost 2 separate strands. The first was that I was supposed to write a book with a friend many years ago, and I didn't do it, and he wrote the book and got it out. But there's always this thing of, well, I kind of let him down, I let myself down, so I should write a book one day. And that was at the back of my head. But also, I joined ThoughtWorks in 2004, and I left them just over a year ago now. So I was with ThoughtWorks for 12 years. And in the first sort of 6 years of that sort of time in ThoughtWorks, so from 2004 through to 2010, my main focus was on how do I help people ship software more quickly. So you've written some code, how do you get it into production as quickly as you can? So I was focusing a lot on build automation, infrastructure automation, spinning out machines, build pipeline design, CI, servers, all of that sort of stuff. And I realized that you can do all of that, but quite often you have a problem that the design of the software itself doesn't make it easy to release software quickly. When I think about fast release of software, what I'm thinking about is frequent releases of small pieces of functionality. That's always my goal. That's how I optimize how I ship software. And so I started looking for software architectures that would optimize for frequent delivery of small pieces and small changes in functionality. And microservices was sort of a trend identified by a colleague of mine, James Lewis, and that sort of seemed like it solved a lot of the issues that I'd been facing in my CD work. And so I thought, well, there's something really interesting here. So I started doing talks and exploring the space a bit more, and then sort of realized there was something here, but it was so cross-cutting in its implications, and that there was a lot of knowledge that I and others had started to build together, that it felt like, well, okay, these 2 strands of, I always wanted to write a book, and actually I think I've now got something worthwhile saying came together. And then it was a process of realizing that a number of my friends have written books, and I saw how crazy they went. Like a few of my friends, it took 3 or 4 years over one of their recent books, and it was like, I don't have that attention span. I'll go insane if I spend 4 years writing a book. So I gave myself a year, and I just said, if I don't write the book, I'm never going to write the book in a year. So I just did it, and didn't go out with my wife, didn't go down the pub, stopped playing computer games, but I got it finished. So I started in the 2nd week of January, I think 2014, in India, Bangalore, India, and I finished the middle of November in Oslo. And I then went out and had a steak dinner. And if you know how expensive Oslo is, you know how big a celebration it is to have a steak in Oslo.
I know. That's awesome. That's an awesome story. I mean, you start your book in India and then you ended up finishing in Oslo.
Yeah. And I live in Australia, and I'll be leaving Australia in about 2 months, moving back to the UK. So yeah, it's been a book that I've written bits of, probably in about 10 countries. So yeah, I'm hoping the next one will be in one place.
Yeah, so a multicultural book, and you were able to get a different influence from different countries on the book. So that's awesome.
I was very fortunate that aside from, I was in, ThoughtWorks when I left was about a 4,000 person company. When I joined, it was 400. But, having that many people around, so many projects going on, and I was in a position where I could talk to, probably when I left, we had probably 60 projects on the go at any one time, chat to people and see what was going on. And in addition, I think we're quite fortunate that we work in an industry that's very open about sharing. And so I found it very easy to, ping someone at Netflix and bend their ear, or pop over to SoundCloud. And, people are very generous with their time, especially if you're going to write down things that other people can learn from. So I'd be very fortunate that sort of I had a lot of access to lots of people's great ideas and an awful lot of work that came before. And since finishing, I've learned a lot more since. So it may well be that when we ask these questions, and I'm answering these questions, that I may even contradict some of the things I said just about 2 years ago now. But I guess we'll get to find that out as we go on.
I mean, well, things change. So, but let's. I want to start with the basics. I mean, we have a lot of people here that probably haven't heard about microservices before, and even I think that some people don't even agree on what the microservice is. So, in your own words, I would like for you to describe what do you think what a microservice actually is.
Yeah, I'm fairly simple in my definitions. I don't use a very prescriptive definition of what a microservice is. I just say they are small, independently deployable services that work together and are normally modeled around some sort of business domain. So when I say small, independently deployable services, typically we're talking about separate processes. The communication is via some sort of network-oriented communication protocol. It could be REST. It could be RPC. I'm not overly worried about that. I think there are some implications for how services talk to each other. The key thing is, though, these are independently deployable services. So I can make a change to a service, deploy it independent of other things, and that primarily they are modeled around business domain because some experience has shown us that leads to very stable API design. Some people get prescriptive and say they have to use HTTP and have to be synchronous. No. Some people say, you've got to use Akka and all be reactive. And it's like, you can if you want, you don't need to. So that's what they are. And there's a lot of different flavors of them. But the key things are independently deployable services that communicate over some sort of network-oriented protocol that are optimized around independent deployability.
Okay, so we actually have our first question coming from RC. From the user Yogs, he's mentioning that it's very interested on the premature decomposition section. I'm not sure if you have that on your memory. I actually read it yesterday on your book.
Wow, I'm looking at. I'm not checking at all.
Okay. I actually ordered the book like 3 weeks ago, and I want to have it here to show it. But I guess I hope it's awesome that you have it there to show it to our users. But it didn't arrive yet, so I was kind of pissed.
That's fine. I am more than happy. I would have sent you if you two had told me you're helping me get the word out, I would have sent you copies. That would have been fine. Yes.
Anyway, so Yogs is asking, so he's quoting you on a sentence that you wrote there, saying like, in many ways, having an existing code base you want to decompose into microservices is much easier than trying to go the microservices from the beginning.
Yes.
How do you feel about that? Do you still feel that's the way, or do you feel differently now?
In general, I feel the same way. The reason I feel that way is because one of the most costly things you can get wrong with a microservice architecture is getting the seams in the wrong places. You suddenly find that to make a change, I'm now having to change and coordinate deployment of 2 or 3 or 4 services at once, for example. That actually increases your cost of change and decrease it. And so the trick is always, how do I find stable API boundaries, stable sort of service boundaries, where functionality is more likely only going to sit within one of those boundaries? And to be honest with you, that is a function of the domain you're operating in, the features that you're working on, and your team composition. And when you start on a brand new project, you've got no code. You may not even know what the features are entirely. It's very difficult for you to know straight away, okay, this is what it is we're building. You're actually in a place where you're probably there's a high degree of churn with your code base early on with a brand new code base. And when you put API sort of service boundaries in early on, that actually can become a problem. The story I share in the book is actually from a ThoughtWorks project that SnapCI was a product where they broke things apart too early. Now I still see this as an issue. Now I don't say when you start a brand, and I did a blog post which I'll actually share. Hang on.
Yeah, you can do it on Twitter, or you can send me the link, and I'll be happy to relay it back here.
I'll send it over to you now. Yeah, I actually wrote up a blog post 2015 called Microservices for Greenfield, and I explore this topic a bit more. So I'll just put that in the chat window for you, and you can pass it on to the IRC people. I've got a small laptop screen, so if I have all the windows open, I'm going to lose you guys.
Yeah.
There's actually been some research done looking at the cost of maintenance in code bases, and they found that actually the highest cost of maintenance in code bases is in the interface between things. There's a very good talk by Adrian Collier at the MicroExchange conference in London in November last year, where he talked about this research. Something like 70 to 80% of all maintenance costs around API of changes in interfaces. Now, if you think about a service boundary, that is a much higher cost of change than the internal API change. And so for me, I feel that you would need to let the domain stabilize before you create those service boundaries. That said, at the very beginning, you might think, do you know what? There's this little idea here. That just feels obvious. Okay, we'll make that a service, but maybe keep the rest of the code in one place. I still like the idea actually of creating early on a modular monolith. So keeping your stuff in one code base, you think these modules are going to be services. So keep them in the same code base for now, but actually have proper APIs designed for them within your code base. So I still believe that. Now, I have absolutely spoken to people that have started from microservices from the beginning, and it's all been fine. I've also spoken to a lot more people that have had problems. So you may well find that it's worked great for you, which is fantastic. But for me, it's all about the cost of change of those APIs, of the cost of change of those service boundaries. And that's where the biggest cost is.
Yeah, so, and to follow up that, we have another question saying, so will you recommend, I mean, I guess that you already discussed this a little bit, but will you recommend that you should start with a monolith and then go the microservice way?
All things being equal, for a brand new domain, brand new product set, nearly always, yes, I would. I will caveat that with saying a couple of things. You might be operating in a domain where you have a lot of people. So if you've got like a team of 10 people, fine, great. A team of 2 people, fine, great. You can all get together and work on one code base. The more people you've got, the harder it is to collaborate around a single code base. And you have all kinds of nasty anti-pans. So I would say, in general, yes, monolithic system. When that team starts getting bigger and bigger, or you've got 2 or 3 or 4 teams, I may then look for separating out work streams. And that might then lead me to having a very simple, basic service architecture initially. Likewise, if you had some particular, but if, yeah, actually, yeah, that would be it. So otherwise, I would always start with a monolithic system. And then as things stabilize, I would then start peeling these services out when you feel that those concepts are stabilized sufficiently, or when other forces cause you to do it, such as we need to scale it, we need to have single tenant data or something like that.
Yeah. So, and switching a little from the content. So we have a question here from Mijenko, I think. So what will you recommend for backend to front end, using an API gateway or not? And if yes, do you have any recommendation on which API gateway, open source or not?
Yeah, so this is an interesting one. So the vast majority of API gateways out there are designed for protecting perimeter API services. And they are optimized normally around those kinds of considerations. So they are looking at things like management of third-party API keys, throttling of traffic, logging of traffic. A number of them, that vendor space, some of the solutions in that can be very expensive. Some of them, the way those solutions are deployed, add a significant amount of latency. An amount of latency that for calls at the perimeter of your system, to say third parties calling into your networks, may be completely and utterly acceptable. But if you think about what happens when we break apart a monolithic system, what were in-memory calls are now, cross-network calls. If you're putting, say, API gateway round trips in the middle all the time, you can significantly increase latency if you just drop an API gateway as a general purpose solution for all API to API communication. So I would use API gateway sparingly. I would think differently about the needs of perimeter protection versus inside my perimeter protection. As always, I would probably lead this with some form of threat modeling to understand what the risks are, what kind of information is being communicated. In terms of tools out there, the open source API gateway space isn't fantastically well served. Kong is probably the most well-used solution, and I was doing a bit of work with that recently, using Kong for generating and using JWT tokens and things. That's not bad. That's got quite a pluggable system. That's something you can install and manage yourself. There's a lot of the commercial tools out there, people like Apogee, for example, and Mashery, are sort of now refocusing on that internal concerns, and they're not doing it very well, in my opinion, at the moment. So I would very clearly do threat modeling, think differently around the perimeter versus, inside your perimeter, and be very careful and measured. And so if you haven't done some threat modeling, I would just read some blog posts on it and do some basic stuff yourself in-house before you jump to a solution like that. That would be my general approach. I would say if you're looking for, I know a number of people that have been very happy with Amazon's API gateway. If you've got solutions deployed on Amazon, using that seems like a bit of a no-brainer. I know a number of people who are using both Amazon API gateway and Kong, because Kong does different things. Those things can become quite complicated. So I think it's really careful you understand your use cases and what problem you're trying to solve.
Awesome. And to follow that up, we also have this question from Pefleras, where he says, do you think microservices is suitable for on-premises applications which usually run on only one server? Is the overhead of microservice operations provisioning cost too high for this use case?
There's a couple of different things there. So do I think microservices architectures make sense when you typically only deploy into one machine? They can do. I mean, obviously, from a resiliency point of view, hang on, I've got a plane going. I live in a flight path. This gets quite loud. Hang on. Obviously, resiliency concerns aside, there can be some challenges when you deploy onto one single server. When you're talking about independent deployability, what you're trying to do is reduce the risk of deploying one service independently of other services. If you're all on the same machine, and I say, let's imagine I use a script to reconfigure that box for my new service, I might inadvertently kill the other services that are running. My newly deployed service might use all the resources on that box that might affect somebody else. The other thing that can happen is that quite often you'll run these as fully separate processes. If you're using a technology stack like Java, for example, the per JVM overhead adds quite a lot of memory. That might mean you need more physical resources. Those are all problems with it, and those are reasons why, in general, most people who use microservice architectures tend towards having some form of separation for different services. But that separation can be virtual separation, as in I can have one physical server broken up into virtual machines, or increasingly container separation, where I can have very lightweight separation of effectively like independent of isolated execution environments for my services. Those things can mitigate the challenges of all being on one physical machine. So it's definitely not a non-starter. Now, the other side to this is the word on-prem. What that often means is I'm writing some software that my customers themselves are going to install. So they download my product and they install it. There, microservice architectures become much more problematic. If you're delivering your solution is effectively a black box, like you just give them a virtual machine appliance, they don't need to know there's 25 services on it. They don't care. That's pretty much the only way I can see those things working well. Just think about it. It's December, and when your customers normally install your product, they just run one command line and and they install your product. Great. And on February, you say, right, now to install our product, download these 25 RPM files and deploy them. And here's all the configuration files. And they're going to tell you where to go. And so the issue is when you're going to these fine-grained architectures, if you're going to be expecting the customer to bear the burden of deployment, in general, what you have to do is find some way of hiding that complexity, maybe just deploying it as a one appliance, or doing that deployment on their behalf outside of very specialist cases. And in most clients I've worked with, I'm actually chatting to one organization at the moment in this situation, it actually becomes a break on how aggressively you might decompose your architectures. Maybe you only have 2 or 3 moving parts rather than 50, for example.
Hey guys, I have to tell you that IRC is super active here, so we have like a lot of questions going on.
Excellent.
So sorry if we are not following like a direct path and like jumping from topic to topic because people just send in the questions.
One thing I will say to people out there on IRC, if we don't get to a question today, just ping me on Twitter. And I'll aim to answer as many questions as I can on Twitter. But we are coming back we've got 2 more of these sessions coming up as well. So
yeah, exactly. Remember that we're gonna have 2 more sessions. We already have the dates there. We haven't announced them yet, but there's gonna be 2 more sessions. And I mean, if there's still need for it, we'll do a 4th one if Sam has the availability for it.
Yeah.
Anyway, thank you so much for all your questions, guys. So continuing, getting back to the monolith again. So question from Alasdar. When you have a monolith and you want to replace it with microservices, do you have any tips on how to identify the boundaries or the future boundaries?
Yeah, I mean, I think there's sort of 2 angles that you can come up here. The first is a pure sort of BDD type approach where you start identifying your domain boundaries, your bounded context within your architecture and saying, okay, well, we think this code here represents a bounded context, this functionality represents a bounded context, and so therefore this thing can become a service. And I think that's one angle you do need to approach it in, because experience has shown us that modeling services around bounded context lead to more stable API boundaries. However, that's not always a good. Just saying, okay, I've identified 12 bounded contexts, let's have 12 services. That's not always a good use of your time. There is a reason you're thinking of moving to microservices. What is that reason? That's the very first thing you're going to think. Why am I doing this? I'm hoping the answer isn't just because A, I heard it down the pub, B, I saw conferences about it, or C, I want to put it on my CV, right? There's got to be a really good reason you're doing this, right? What is the reason? The reason is because we want to ship software faster. Okay, great. So if you want to ship software faster, how fast are you shipping software now? Can you measure that? Right, you put a measurement in place, maybe you track cycle time. Right, now let's start looking at our monolith. If you want to re-architect your platform to make it faster to ship software, then actually, you probably only want to focus your attention on those parts of the system that are changing. So what do? You look at the backlog of work you've got and you say, well, look, a large amount of it are in these areas. Okay, now let's look at those areas. Could we pull those areas of code out? So if it's based on, I want to ship software more quickly, you really want to target it based on changes that are going to impact that cycle time. flip it around, maybe the reason you're moving to monolith from monolith to microservices is because you need to achieve more scale. Well, in which case you need to understand what parts of your application need to handle more load. Then you look at that and think, well, this is the sort of functionality you want to pull out. Then bring in that domain-driven design thinking and use that to, within those sort of rough areas of code, identify some clear boundaries to pull those out. I think it's okay looking across all of your system and doing some context modeling and identifying the overall sort of what you think are the higher order functions going on. I think that's perfectly okay. But the first thing you pull out is got to be getting you somewhere. And that's always the thing I'd say about any movement from a monolith to a microservices-based architecture. There is a reason you're doing it. Do you know why you're doing it? Can you track whether or not you're going in the right direction? Like, so faster delivery time, I'll do cycle time tracking, right? That's what I'll be looking at. Cycle time tracking and like release rollbacks. Looking at that, recording that. Okay, so it was 28 weeks. We spent 6 months re-architecting our system, and now it's 40 weeks. Well, we've got worse. Let's stop what we're doing and do something else. You need some overarching view, which is we're doing this for a reason. Have we achieved that reason? And are we going in the right direction?
Yeah, I mean, I also had that experience with working some customers, and I do think that some of the reasons why they are moving to microservice are those A, B, and C's that you mentioned about rather heard it on some conference or heard it on the bar, or they want to put it on CV. So do you believe that there are cases where customers or even whatever team is working on, they don't really need to go to a microservices architecture and they can just keep like a traditional architecture as a monolith or whatever other architecture they're working on?
I mean, it's different because some clients, I mean, I get involved with clients nowadays in one or two places. One, they've started this journey already and they're hitting issues. And there are lots of issues to hit. I mean, I'm hoping that most of my book sort of makes you aware of pitfalls. I hope 2/3 of this book should be about the problems you're going to face, because you will face them. Right? I mean, distributed systems are hard things, and that's not new information. And so they've already made a commitment down that path. And so often there I'm getting engaged and I'm dealing with quite detailed issues that are in the mix. I prefer, if I can, to get involved at the beginning, because then we can actually put some stuff into place and said, okay, we'll achieve this. This is the goal we're trying to get to. Okay, so how are we going to make that work well? We're going to put this tracking in place. We're going to run this pilot for this length of time. We're going to check in 2 months from now, see how it's going, and then roll it out. And that gives you more places to go. You know what? We went into this thinking this was how we were going to solve this problem, but actually it's not working out. Or we found a better way of solving that problem. Right? We found a different way of solving that problem. Because if your goal is ship software more quickly, and you start and you don't have good CI, and you don't have good automated tests, and you don't have an infrastructure automation, and you don't have an automated deployment, actually, if you did those things first, you're likely to get more benefit for less money. And so that's sometimes I have absolutely gone in and said, do you know what? I think it's probably not for you. Now, one thing I do, though, is when we're not sure is, I am a firm believer that we have it in our ability to write monolithic software, so software that is mostly within a single process, that we do have it in our ability to write that code in such a way that it is easier to work with by actually using concepts of modules from the 1970s. And so I've worked on a number of projects where actually what we did instead was we actually started off everything in one code base, and we just thought use modules and use those concepts of modules, and that made the decision later much easier. So we could take one of those modules and then convert it to a service much easier. So I think even if you're thinking, well, maybe microservices aren't for us, there still can be very good reasons why having some form of modular decomposition within your monolith makes a lot of sense. If for no other reason, that actually it can make your builds much faster, because you can build and integrate those components independently.
Awesome. Hey, Ivan, do you want to send in one of your questions?
Okay. It's the session is half gone, so my first question.
Yeah.
Great audience today. Thank you very much for your questions. So a lot of people compare microservices to SOA. So, Sam, would you explain what is the difference and why do you think that the future of microservices will be different than what happened to SOA? And we all know what happened to SOA.
Yeah, I think it's interesting because I think some people talk about SOA and microservices as being different. And I view things slightly differently. And I think it's partly because I think early on, service-oriented architecture got conflated with web services. And so they became this different thing. We saw SOA as really SOAP-based implementations of architecture. The viewpoint I take with service-oriented architecture is nothing more or less than the idea that breaking apart our systems into services that communicate with each other over network boundaries might be a good idea. And actually, that's all SOA is. It is very truest essence, and it wasn't overly prescriptive about how you did that. Then at the same time, you've got this web services stuff that's coming up. That's being, you can see in things like XML RPC and then the SOAP stuff that's coming along. And so people took this idea of service-oriented architecture and implemented it using all the SOAP stuff. And what we came up and what we realized was that was a lot of the time the SOA implementations I saw were focused on implementing SOAP-based protocols and standard-based technology. And often these standards were things which were clean room implemented and hadn't actually emerged from real world use. And their focus was on that, and their focus was also on reuse of code. And it's a very subtle thing, but I actually think when you focus on reuse of code, you get some really disturbing things happening. Like people make services that are overly generic. And the lack of focus in a lot of service-oriented architecture implementations, traditional service-oriented architecture implementations, a lack of focus on things like independent deployability, which led to the situation where you would always have to do lockstep releases of 25 different things. So I think the idea of service-oriented architecture is absolutely fine. I just think the way we chose to implement it a lot, and I include myself amongst that for many years, led us into some bad situations. Some people say that that microservices is SOA done right, and I'm kind of okay with that, right? So I think what happened is after 15 years, 10 to 15 years of doing SOA, we realized the things that worked well and didn't, and sort of distilled it down and came up with a coherent set of things that seem to work well together. And so another analogy I use is you can think of like the Agile Manifesto as a set of guiding principles about how you do software development. But it's not prescriptive enough. You couldn't use that as a playbook of how to do things. And so then you have things like Scrum or XP or Crystal or DSDM, which are different ways of implementing Agile. So I think of microservices as a way of implementing the ideas of service-oriented architecture, but that rather than focusing on specific technology, it's instead focused on this idea of independent deployability. So really focusing and optimizing on making it as easy as possible for you to change parts of your system without changing the rest. And so it's a subtle distinction, but I don't think they're not contradictory. I think it's just it's almost like a better way of doing these things.
Mm-hmm. So keeping up with our RC questions now, a question from VT. He's asking if microservices are supposed to get rid of ASBs.
Well, okay. So the principles I outline in the book would guide you away from traditional enterprise service bus implementations. So one of the challenges often, so I like using message brokers. I think they're a very useful piece of technology. The temptation is often that you put functionality and behavior into that service bus that are often domain-specific behavior. And what that leads to is a leaching of business logic away from services that are modeled around what you want does, or services modeled around business concepts, so that the code that chains together stays together, right? So you get these stable boundaries. Enterprise service buses, when they have logic in them, that logic starts seeping into these message buses that then unfortunately over time become a constraint. making changes becomes quite expensive, and often in organizations that have enterprise service buses, it's somebody else's team that deals with it. So in general, the way I like using message buses is this idea of smart endpoints, dumb pipes. So treat your message broker like a dumb pipe. Buy a really good one. By all means, spend money on it, right? Spend money on TIBCO, on RV, get a great Rabbit set up. But treat it as an excellent and reliable way of getting a message from A to B. But you should know nothing about your domain, and then put the smarts in your services. That way, you can still make use of some amazing underlying technology that underpin enterprise service buses, but you're not necessarily falling into a trap of centralizing a lot of behavior, logic, and power, which can become often a sort of a form of gunk that bungs up the system a little bit.
Awesome. So now the next question is coming from Vishwas. He's asking if there is an existing application which uses a relationship database heavily, how do you separate the services?
Yeah, it's a really, really good question. One of the most common service integration patterns that we see out there is often just a lot of services sharing one database. And when I talk about a database, I'm talking about a schema here. Some database platforms, I have the separate idea of the database instance and multiple separate schemas. I'm talking about a shared schema. And the reason we do it is because it's really, really easy. I think I tell a story in the book. I can't remember if I do or not. This is a true story. I was working at a German investment bank in 2007. And we were pricing credit derivatives. If you know much about credit derivatives, you know that I'm partly to blame for the global financial crisis. But we had this schema that we were the main pricing engine, and we had this schema where we were storing all the prices, and we were the main system of record for this information. But we had some upstream applications that dumped data in that we used, and some downstream applications that then actually took data and even manipulated it. And we needed to completely redesign our schema to hit some different performance requirements that we had. And we couldn't, because we didn't know who was tracking actually using our application. We tracked 40 separate services using our database at the same time. And it became a nightmare. So the only way we could actually find out who was using our database was to turn it off during the day and wait for phone calls.
Wow.
Right, so that's a bad place. And what you see is, over time, shared schemas become a coupling point. And I talk a lot about in the book about this idea that really, ideally, a service should own its own data, and be able to make a decision about what is shared and what is hidden. When you just expose a schema, you've exposed everything. Now you've exposed your internal implementation details, and now everybody sort of binds to that, and it becomes a constraint, a coupling point. So in general, what you want to do is take those relational schemas, and before you break your services up, actually break the schemas apart. So I think in chapter 5, I've got a lot of detail actually about examples and patterns of how you refactor those databases to pull them apart, so that you can make small incremental changes to your data schema to pull them apart to allow service to own their own data. There's also a bunch of other tricks you can use. You can do things like have explicitly published reporting databases for read-only purposes. There's stuff you can do, which I talk about, around using things like materialized views. But in general, the idea is a service should own its data, and anything else should be exceptional. And it's painful to do when you're going to break apart a large schema, but it's often worthwhile. And so yeah, I think it's chapter, I'm just going to check now. I'm pretty sure it's chapter 5. I go into a lot of detail on that. I also did a talk in 2012 called Designing for Rapid Release that touches on some of these ideas as well, but I wasn't talking about them as microservices back then. But yeah, there's a lot more detail in there.
I see.
But in general, you need to pull those things apart.
And continuing on that conversation, I mean, if you have like these huge database or these huge schema and you split that apart, sometimes you end up with services that actually touch the same data, but we are discussing that those microservices should have a separate data piece for their own work, right? So yeah, you end up with sync problems, right? When usually you have to update data on one service and then the other service has a copy. Not exactly the same, but they touch the same boundaries.
Yeah,
like.
so you have to be extremely careful about knowing where data came from. Is this my data? If this is my data, I get to change it. If it's somebody else's data, I don't get to change it. What I've got is a copy. Those in separate places. You store a copy for different reasons. You store a copy for performance, right? So that's what you've got to do. You've got to really separate those ideas in your head. So if I needed to, for performance reasons, copy another service's data and have it stored locally, I would not have it in the same schema as my database, or I'd very clearly delineate that these tables are separate things. So I stick it in in-memory cache, rather than just sort of having some bulk sync. And the worst thing you can do is, so you've got some data you own, you read and write that data. I then copy that data and then I change that data. Mm-hmm. Right? That's a broken idea, because who's got the right source of data?
Yeah.
Right. So that comes back to this idea of domain-driven design. What we're often looking for are bounded contexts. Bounded contexts are all about thinking of models and where those models can move and how they can change. So really, if I want to change a piece of information, I should go to the place that owns that data and ask that thing to change that data on my behalf. Because it can then have all the code and have the state machine around allowable state transitions.
Mm-hmm. Yeah, so coming up for our next question, this is coming from Omihali, I think. I'm not sure if that's how you spell it. Anyway, so he's saying microservices enable polyglot services, but my experience that using too many different languages is not manageable. What do you think about using a single platform like Java or Node.js for implementing the microservices, or limiting the number of technologies?
I think the question is it's a very sensible question. I mean, and the key thing was there is microservices give you the option to have loads of languages, loads of different technology stacks. They don't give you the requirement. I firmly agree. Having loads of different technology stacks can be very difficult to work with. So I think having a default choice, or maybe two default choices, is very sensible. I like some level of standardization because it makes things simpler. So I like standardizing an operating system, for example. I think if you standardize on JVM-based services, you get to know how a JVM operates. And that still gives you different languages that you can use within that. Some people like Scala. I don't, but there are other people out there, you know. So yeah. And it's sort of interesting. I spent a lot of time with SoundCloud over the last year or so, and it's sort of interesting to see there that when they started their journey, they had this huge explosion of languages that were being used. People using Haskell, Julia, Clojure, Node, Scala, plain old Java things. Wow. And it's just because what they said was they empowered the teams to create services how they wanted to. But over time, they built in-house tools that made it really easy to create services if you were using Scala or Clojure. And so over time, just naturally, not through a diktat, it just became, well, I could write this myself in Haskell and it would take me twice as long, or I could just use the off-the-shelf stuff we've got already built in-house and I could ship this in half the time. I'm going to ship it in half the time. And so naturally, over time, they've now made their Scala in Berlin and Clojure in New York, more or less. And so I think that's a natural thing. I think the key thing to understand is you have an option. If you want to try out a new language, a new tech stack, you could do it in one place and just try it out. But yes, certainly for small teams, having a default choice makes a lot of sense to me.
Mm-hmm. So returning again to the API gateway, this is a follow-up question from Milenko. He sent a question from the API gateway before. Mm-hmm. So regarding your answer, will you then avoid the API gateway completely or not even use it for authentication from the outside? What will be used instead? Will you use it for service discovery?
Okay, well, so the problem is that the term API gateway can mean a whole bunch of different things. So, and you can put absolutely any single thing into that box that you want to. There's no tool out there that calls itself an API gateway that I would use for service discovery necessarily. The needs of service discovery are quite specific and are quite different, and the requirements are quite different. And so I would use different tools for those purposes. I often, when people you might use a service discovery system to configure routing in an API gateway. But that's probably about as far as I would go. Yeah, that I don't know if I've fully answered the question, but I sort of, I probably wouldn't. I'd only use an API gateway at the moment on perimeter. I might have more than one perimeter. Something I do certainly on platforms where I've got access to some form of software-defined networking layer is to sort of have services demarked into different categories. And so I might say these services can talk to each other freely, and these services can talk to each other freely. But if these services want to talk to these services, there needs to be some kind of communication or vetting or process going on. And what I might do is put them onto different subnets if I was using, say, some sort of software-defined networking layer, and use peering, and I might put something at that layer. The issue at the moment is that communication between services, it's very hard to come up with a solution that is performant enough for most people's requirements. And also you have to deal with two separate issues when you're talking about services talking to each other. One is dealing with, is this service allowed to talk to this service? Is this service who it says it is? And is it allowed to talk to this service? And then the second thing is, this service, and we know what it is, and it's allowed to talk to me, who is it asking on behalf of? There's a class of security problem called the confused deputy problem, which is especially rife in microservice architectures that is very difficult to deal with unless you're doing something like using cascading JWT tokens. And I have met very, very few people that do that. In practice, as far as most people go, are doing things like assuming implicit trust in terms of service-to-service communication, and or using something like PKI, so using, say, client-side certificates for people. So one service A has a certificate that allows it to call service B, but then assuming that if it really is service A, that anything it does is okay. It's only people are doing stuff with OpenID Connect and JWT tokens, typically just at the perimeter, that is starting to change, although it's very, very early days. And to be honest with you, the vendors in this space are scrabbling to keep up. And so if that's the sort of solution you're looking to build, don't be at all surprised. You're going to have to do an awful lot of it by yourself.
Mm-hmm. Yeah, so let's go to the next question. That's coming from Alasdair. So considering the hypermedia as the engine of the application state, what will be a good way to share the initial entry points? Maybe have some kind of index of microservice entry points or something like that?
Well, it's sort of, okay, so there's two parts to this. There's one is like, how do you have things wired up in your system? If all of your services are just HTTP sequence-based services, they're just having a simple routing layer, like running an Nginx proxy as a routing layer or something, can just be good enough, actually. You can just manually configure it. If you've got 10 services, then that's enough, right? You go in, you put an entry in, you say, when I go to services.mycompany.com/customer or /inventory, then inventory goes to inventory service ring on this machine. And that's often good enough for that stuff. And you can do it manually. And often just do DNS-based stuff. You update the DNS entry for that item, and it just points to a load balanced set of those inventory nodes or whatever else. As you get a bit more sophisticated, as your environments become more dynamic, so as you're bringing those up, you're shutting them down, then you're going to start looking more and more for some form of dynamic discovery that goes over and above what typical DNS provides. So DNS is a service discovery mechanism. It's based around different requirements. So there are tools out there like etcd, Zookeeper, and Console that are distributed systems designed to have sort of some sense of sort of shared state that can be used for service discovery. And so when I launch an instance of a service, I can tell Console, oh, hello, I am an inventory node and I'm on this is my IP address. And then people can go and ask Console, give me an inventory node. I actually quite like Console as a tool from HashiCorp because it's quite it supports its own bespoke query mechanism that allows you to query on name value pairs just over a REST-based mechanism. It also just works as a drop-in DNS server, though. It does DNS serve records. One of the really, really cool things it can do using a tool called Console Template is it can update text files based on its entries, which seems like a silly thing until you think of that Nginx proxy I mentioned earlier. So when you added a new node into your console, Console Template will automatically update your Nginx configuration and add the new entry for your node in. So I deploy a new instance, all of my configuration files can update dynamically, allowing you to do things like client-side load balancing or network proxies. I always suggest don't start there. Start with something easy and simple. Start with convention-based names. Start with just simple DNS. Over time, if you need something more dynamic, having a dynamic registry that's created by something like Console is well worth doing. And I think Console's got the best feature set of all of them at the moment.
So the next question is coming from N. Rusev. Do you think that companies will rewrite their monoliths into microservices? Because every software has problems that microservices can solve, but do you think there's enough budget and time for that?
Well, it's sort of interesting. It's in many organizations that budget's hidden away. The vast majority of people that come to see me talk, and I'm saying 75% of all the people that come see me talk are in organizations that have a monolithic system that is, okay, I'll take that back. They don't have a monolithic system. They have a system that's too big. Vast majority of people, when I say how many people here have got something that's too big, most people put their hands, 75% minimum, especially when I do my training courses and things. Everybody is looking at a way of looking at microservices as the way to make their software easier to understand and easier to make sense of, because they've let the old system get too big. Now, it's interesting because I don't think too big is a lines of code thing. I think too big is the moment you don't understand it is too big. It could be 50 lines of code and too big if you don't know what the hell's going on. It's not the only way to achieve those goals, but it's currently the way. And there's an awful lot of people out. That's why I'm so busy, which is great for me. But everybody's doing it right now. I think the interesting thing is when you go to organizations where IT is still quite separate from, say, the business, IT will just say, okay, we're going to do a re-implementation to microservices, and the reasons given are often fuzzy, but they'll get the budget. In organizations where I see that the IT and the product side are much more working closely together, I sort of tend to see the move to microservices being a bit more sensible. There's a customer need that is driving this change. The customer need is we're not shipping software quickly enough, or we want to satisfy our product. And when those are driven by product needs, it actually becomes even easier to get the budget, because it's the person who makes the money wants to achieve a goal that you can help them with through microservices. And once you explain that to them, they go, here's all the money. And so that tends to also lead to healthier outcomes, I find, rather than just saying, let's do microservices because Netflix, which is not a good answer.
Mm-hmm. Okay, so we have 5 minutes to go, and I still have a couple of questions on RC, so let's see if we can still go for them.
Sure.
So Alastair again. So he's now saying, in your book, you say to defer versioning microservices for as long as possible. Assuming that your sure versioning will come in at some point, and when you do version a microservice, you want to go to the route of including the version in the URL. Should that be done from the beginning? So start by having microservice file in the form v1/my microservice from the get to go.
Yeah, I have no real problem with doing that. I mean, there are some people out there that are horrified at the idea of putting version numbers inside URI paths, and I'm a lot more relaxed. I don't think you have to put them in at the beginning. I mean, I think in the past, what I've done is if you don't include it, I assume it's latest, and then just I use routing to send you to the latest. But yeah, sticking a /v1 in there if you want. I don't actually think it's that big a deal to add in later. And if you use a service discovery tool, you have the ability to ask for a specific version of a service. And that can often be quite important. So you often have to do that just for compatibility reasons. You know, I do talk about in the book the idea that you really want to avoid running multiple different versions of the same service at the same time. There are situations where you can't avoid it. So yes, you could have versions in your URI paths, but there's also, these services don't only communicate over HTTP. Some of these services will use message buses. Some of these services might use protobufs. Some of these services may use, you know, different forms of comms. And so by all means, yes, stick a version number in there. I don't think it's a big problem. I also don't think it's that hard to add later on, but that might not be the only place that versioning becomes important. And that might be why, therefore, having some form of service discovery tool, which can store a lot more data about services, could become more useful over time.
So now I think we go for the last question here from G01. So if you use REST over HTTP, this implies synchronous communication, so orchestration. However, the recommendation is for choreography. Will the preference to be use REST over HTTP for communications with the client and for us to use choreography between internal services? Are there suitable message brokers supporting REST over HTTP with all the TP verbs? What transport mechanism will you suggest for choreography? gRPC or something else?
I mean, the key thing, okay, so there's a bunch of stuff in there. So when I talk about orchestration versus choreography, I have a personal preference for choreography. I'm specifically there talking in the context of asynchronous forms of communication. So I talk about, there's sort of, I talk in the integration chapter of the book about, we have request response based communication, we have event based communication. And then we have asynchronous and we have synchronous communication, and they sort of map in towards each other. And so when you have event-based systems are choreographed-based systems almost by their very nature. But you can use asynchronous request response, which effectively is what we talk about as being an orchestrated-based approach, which is typically directed, often one thing in the middle telling other people what to do. And so that's really comes into play when we're talking about asynchronous types of communication. So I tend to keep, I like my software like I like my worldview, simple. I like the world to be simple. I don't want Donald Trump getting elected. I don't want Brexit. I want things to stay as they are and be very clean and very easy and very simple. So I tend to just start with saying my default approach is HTTP because it's very well supported. Every tech stack has got stuff out there and it's got some amazing capabilities. There are times when that is problematic. The biggest problem you'll hit, especially if you're going quite fine-grained, is latency. You'll start getting latency build up. You know, I've got a service that calls a service that calls a service that calls a service. Then you might start looking at asynchronous forms of comms. Now, I do actually think that looking at something like gRPC might be useful when you start worrying about latency. Not because of choreography versus orchestration, but purely because it's using HTTP2, which has some interesting performance optimizations that may well make service-to-service communication much more efficient. So when I start looking at event-based systems, so choreograph-based systems, I normally start, my default approach is normally to start thinking of some form of message broker. That's when I'm thinking about a Rabbit, an SQS, maybe a Kafka, if I'm in that kind of space. For sort of asynchronous, well, I just want asynchronous orchestrated. I may still use some form of asynchronous HTTP-based protocol. So yeah, there gRPC may well make sense, which is a full sort of async RPC stack that will sit on top of HTTP2. There's an awful lot in there to unpick. And so, yeah, I do like gRPC primarily because it makes HTTP2 quite accessible. But yeah, my default choice is HTTP, synchronous HTTP, because it's a lot simpler.
Mm-hmm. Yeah, and I think we run out of time for this session. Finish up 10 sharp UK time. Darcy here is going awesome. People are thanking you for all the insightful answers that you gave to the questions. And of course, we also want to thank all the people that participate on the session by RC. So this is not going to be the last session. We're going to have 2 more sessions. The next one's going to be on 9 February. We don't have the event on VJUG yet, but I'll add it today so people can sign up for it. And for that second session, we're going to review the 5 to 8 chapter on your book. Cover sessions like cover topics like deployment, testing, monitoring, and so on. So please stay tuned and join us for the next session. And thank you so much for being here with us, Sam, today. And hope to see you again soon.
Worries. Yeah, and if you want to ping me on Twitter, I'm just Sam Newman on Twitter. So feel free to ping me questions there. But maybe say only about the first 4 chapters if you can. We can do the next ones next time.
Yeah.
Okay, and I'd like to thank everybody on the IRC because this was the first time when I didn't get to ask any of my questions.
Yeah, you did one.
which I prepare very carefully these days. Thanks everybody for being so active, and see you again beginning of February.
Excellent. Okay, well, you take care, everyone, and we'll see you in Feb.
Okay, guys. See you next time.
Bye-bye.
Bye-bye.